All right, so this is video number 4 for section 4.4. This comes from the 1991 BC number 1. Although it says BC, it's really more AB material, but that's what it came from. The particle moves along the x-axis so that its velocity at any time t is greater than or equal to 0 is given by v of t equals 12t squared minus 36t plus 15. At t equals 1, the particle is at the origin, so that's some kind of an initial condition. It's good for us to know. Find the position x of t at the particle at any time t is greater than or equal to 0. So there's where we'll need our initial condition. Because we really know that position is the antiderivative of velocity. So we can say that x of t is the antiderivative of velocity, so 12t squared, that's going to be t cubed, 4t cubed, minus 18t squared, plus 15t, plus some constant c. And then it says at t equals 1, the particle is at the origin, meaning that the value is 0. So it's going to be at the origin when t equals 1. If I plug 1 into all the t's, we'll get 4 minus 18 plus 15 plus c. 4 minus 18 is negative 14, plus 15 is 1, so c is negative 1. Which means that the position of the particle is 4t cubed minus 18t squared plus 15t minus 1. For which, find all the values of t for which the particle is at rest. A particle is at rest when the velocity is 0, meaning it is not moving. So let's go ahead and set our velocity function, 12t squared minus 36t plus 15 equal to 0, and we'll solve for that. So, I think we can factor a 3 out. Might make the factoring easier. So 4t squared minus 12t plus 5. So let's see, 3 times, what are we going to get here? I think we're going to have to do, it's going to have to probably be a 2t and a 2t, a 5 and a 1, because that's going to give me 10, and yep, that's going to give me 12. Both are going to have to be negative. So that means that from the first one, t is a half. From the second one, t is 5 halves. Let's make sure both of those are in our domain. T is greater than or equal to 0, so yes. So at times t equal 1 and 5 halves, the particle is at rest. Find the maximum velocity of the particle. Kind of a tricky question. Normally, if we were going to find the maximum of a function, you would take it from the original, but we want to find the maximum velocity, so we need to take the derivative of the velocity, which is really going to be the acceleration. So we're going to find v prime of t, which is going to be our acceleration. Not that it's asking for that, but that's just something to know. So v prime of t, let's see, v prime of t, trying to do this so I can keep most of this on there, is going to be 24t minus 36. Need to find the critical values. So we'll set that equal to 0. Adding 36 and dividing by 24 is going to give us 36 over 24, which reduces to 3 over 2. So it doesn't say it wants us to find a local maximum or minimum. It wants us to find the maximum, which means that the maximum could occur at an endpoint or it could occur at a critical value. So really what we need to do is we need to test our velocities at the given t values, at 0, 3 halves, and at 2. So if I plug 0 back into my velocity function, we're going to get 15. If you plug 2 back into your velocity function, let's see, that's going to be 2 squared is 4 times 12 is 48, minus 72 48 minus 72 is going to be 24, I believe. Yeah, 24 plus 15 is 39. So far, 2 is the winner. And 3 halves is 1.5. That's probably not something that you're going to want to do without the calculator. So I'm going to scroll back up just so I can use the calculator and see what I'm doing here. So it's going to be 12 times 1.5 squared minus 36 times 1.5 plus 15. Negative 12. Okay, let's scroll back down here. Oops. So really what that tells me is that 3 halves is a minimum. That's actually going to be a minimum. So the maximum velocity is actually going to occur at time t equals 2. So the maximum velocity is 39. Were we given units on this one? Nope, no units. It would be something like meters per second or feet per second or feet per minute or something like that. Maximum velocity is 39. And then find the total distance traveled from 0 to 2. We've done total distance a couple times. That's going to be the integral from 0 to 2 of the absolute value of the velocity. So just for the sake of the fact that I keep forgetting what the velocity is, 12t squared minus 36t plus 15. 12t squared minus 36t plus 15. I'm going to go ahead and write that down. You don't usually have to do that, but I have to keep scrolling back up and down. So now we're going to use the calculator and do math 9. Integral from 0 to 2 of math num absolute value 12x squared minus, oops, I forgot to write a t in there, but that's okay, I'll write it in later, minus 36x plus 15 with respect to x. And the total distance traveled was 17. Most likely all of this could have been done without a calculator because we're getting nice values here. And just remember that if you were not to use a calculator, because the velocity function equaled 0 at 3 halves, you would have had to have split this integral from 0 to 3 halves and then from 3 halves to 2. And then do 2 separate integrals, 2 separate antiderivative techniques for fundamental theorem of calculus. But since we're practicing with the calculator, there you go. All right, that should be enough for that problem. Yep, we're good there. So we'll come back with one more and be done.